Okay. Area. Surface area is the amount of space that something takes up, right? And you've seen this before. So like if you're talking about surface area of, say, the wall, you're talking about if you had to cover the front of the wall. That's what you're talking about. You typically will see with like paint or something like that where you talk about surface area. The first one we're going to start off with is area of a square. We've already done this, so it's kind of a nice straightforward one. The area of a square is equal to its sides times each other. I like to just say area of a square equals length, which I do as a cursive L, times width. Awesome. Example 1, determine the area of a square. Because it's a square, you'll notice these little lines right here. Those lines mean that those sides are the same. Okay, so anything with this line, those are all equal. So if you looked at this square, those lines are telling me every side is 7.2, since the side on the right is 7.2. For area of a square or area of a rectangle, works both ways. You're doing length times width. My length is here, length. My width is here, width. Area equals 7.2 times 7.2. You're going to want to just throw that in your calculator. 7.2 times 7.2 equals 51.84. So the area of that square is 51.84. Now, throughout this unit, you're going to see measurements, right? Like this is centimeters. So the answer is technically centimeters squared because we're doing area. Area of things is always called squared. What I just wrote in blue, I'm not going to mark you on. Right? We talked about this in unit 1. I don't really care about units. So I don't care if you put centimeters or not. The only thing I'm marking is the thing in red. This is what I want to see, 51.84. That's it. Don't worry about units. Yeah.
What about example 1? It says to round to the nearest 10.
Oh, did it say that?
Yeah.
Round to the nearest 10. Oh, perfect. Okay, so instead of 51.84, we would call it 51 point, 10th is the first decimal place. So you look next to it to see if you round up or down. If it's 5 or above, you round up. 4 below, you round down. You just leave it the same. So we would leave this as 51.8. Thank you for saving me, Brian. Awesome. Area of a square, area of a rectangle, same formula. Okay, squares are rectangles. They're just special rectangles where the length and the width are the same. So when you look at this next question, it says determine the area of the rectangle. You're using your same formula, which is length times width. Area equals length times width. This time, we have a length of 17, a width of 8. So we go 17 times 8. If you put that in your calculator, you get 136. Again, if you wanted units, it would technically be centimeters squared. I'm not going to stress about the part in blue. The part in red is what I care about. Okay, so make sure you have the 136 correct. Shh. Next question. Length and width, like you guys usually crush those squares and rectangles. Area of a parallelogram. A parallelogram doesn't matter. So if you reverse your length and your width, it's the same. Yeah, that's a good question. So if you have a rectangle, you're not sure which one's length, which one's width, which I didn't go over, doesn't matter. You can pick one either way. No. No, it doesn't matter. The reason why is because multiplication can be reordered. So length times width and width times length, it's the same formula. So it doesn't matter which one you name which. Okay. Parallelograms. We're trying to start like a parallelogram. Let's try this again. A parallelogram is a shape where your sides are parallel to one another. So for instance, like parallel means if they ran side by side, they'd never touch. If you look, these lines, which I'm highlighting in red, are parallel. They would never cross each other. They're going at the exact same rate. If you look at the other lines across from each other right here, those lines are parallel to each other, the blue ones. They would never cross each other. They could run forever and they would never cross. A parallelogram just has sides that are kind of tilted like that, but they would never cross each other. They're parallel lines, hence its name. The formula for it is a little bit more complex. The area of a parallelogram is base times height. The base, people are usually pretty good at. The height is easy to get confused. So if you're looking at this parallelogram over here, the base is like the bottom. The height is not what I'm about to highlight in red. This line right here, I call it your slant height because it's on a crooked angle, right? That's my slant. My height is what happens when I go directly to the top to the bottom, right? Without any sort of angle. So it's this guy right here in blue. That's your height. Your height has to be straight up and straight down, not on a slant. So for us, if we look down at these questions over here, example 3, and we try to figure out the area of these parallelograms, we want to do base times height. The base is like my nice flat edge that I have. If you look at this question, my base is here in red. That's my base. Because it's on a grid, they didn't provide the length of it. You can count the length of it. If you look at it, it's 1, 2, 3, 4, 5, 6. The base is 6. The height is straight up and straight down, connecting basically your two bases. It's not the angle. I'm going to highlight it in blue. That's my height. If I want to calculate that, I just count it. It's 1, 2, 3, 4. 4 is my height. The area is base times height, which would be 6 times 4.
No,
It's 4. Don't count it. So 6 times 4 is 24. Area of a parallelogram is 24. If you look at B, the parallelograms actually turn. So the base isn't the bottom, right? The base is actually over here on the side. Like that's my base. My other base is this one right here. That's like my flat edge. My height is this guy in blue. If we did base times height, that's 6.1 times 5.5. I'm not using the 6.6. The 6.6 is my slant height. Notice how it's connected to the line that's on an angle like this. That is not my base or my height. Yeah. Oh, do you have the answer?
Yeah.
What is it?
33.5.
33.55, and it said to round to nearest tenth. So if I rounded that, it would be 33.6 because the number next to it was 5 or bigger, so I rounded up. Meters squared. Yeah. For area, it'll always be the thing squared. Awesome. Triangles. Triangles are really parallelograms that are cut in half. So if you look at this question over here on the right, they've drawn a parallelogram for you, and then they've cut it in half. When they cut it in half, they created this triangle right here. And any triangle is like that. So if you drew a triangle, you could do the exact same triangle, put them side by side, and you create this beautiful parallelogram. So triangles are half of parallelograms. Because of that, we get our triangle formula. Our triangle formula is base times height divided by 2, because it's half of what the parallelogram formula would have been. Examples of that. We have 2 triangles here we want to calculate. We'll start with A. You need to be able to do base times height divided by 2. The base is this one in red. The height is this one in blue. Notice that I did not pick 7 or 8 because those were on angles. Right? My height kind of connects like one of the corners to my base. That kind of gives you a little bit of a hint on what to look for.
It's base times height divided by 2.
Base times height divided by 2. So it'd be 10 times 6. That's base times height divided by 2. If I'm putting that in my calculator, honestly, I would calculate the top first. I do 10 times 6 to get 60 divided by 2, right? Kind of following my BEDMAS rules. And then 60 divided by 2 is 30. So I'd get an answer of 30. Yeah.
Do we do squared for this?
Again, you would do meters squared if you wanted to do the units. Yeah. It'll always be whatever the unit is and then a square. B, that triangle looks a little bit trickier. It's hard to kind of tell what the base or what the height is. It's kind of like what's going on. Yeah, so if you're looking, the base is this guy that runs on the bottom. And the height is a little awkward because it's an obtuse triangle. Obtuse means that the angle is really big. It's bigger than 90. So the height is actually outside of the triangle. This is the height over here in blue. That's my height. And so it's kind of hard sometimes to tell what the base and the height are. In this case, it's 5 times 5 divided by 2. That's 12.5 if you put in your calculator. Base times height divided by 2. Wicked. Area of a circle. So things are starting to get a little bit harder. Area of a circle depends on you kind of knowing a couple definitions. Those definitions are radius and diameter. Radius is the distance from halfway or the very middle of the circle to the outside. So if you're looking at the circle on the right, the very middle is right here. If you drew a line from the middle to the outside of the circle like this, that's your radius. A diameter is one end of the circle to the other end of the circle, but you have to cross through the middle. So if you look, this line in blue is the diameter. That's why they put R and D on your little diagram. R for radius, D for diameter. If you're ever not sure, your diameter is always equal to 2 times your radius. It's basically putting a radius beside a radius and connecting it all the way across. They did put that down here, but I'm just going to write it out a little bit better. Diameter equals 2 times the radius. You could also reverse that to say that radius equals half your diameter. So diameter divided by 2. They kind of play off each other, right? If the diameter is twice your radius, then the radius is half your diameter. Kind of makes sense. So I put both formulas there just in case you didn't know that or didn't remember that. The area for a circle involves your radius. So the area of a circle, we use this formula over here that I just underlined in red. We say area equals pi r squared. Pi is a number. Right? I think you guys learned about pi last year. One of you knows pi to like 100 digits on it. Akai, that's right. Pi can do like 100 of them, which is ridiculous. That's very cool. I had a professor who could do it for like a ridiculous amount. There's a world, like, Makai's not here. There's a world record, like they have a championship for remembering digits of pi. It's crazy. They can do like 10,000 digits. It's nuts. Google it. Google it. Yeah, that's crazy. I technically could do it for 2 hours too. I just say 3.1 and then not answer for 2 hours and then say 4. And it still took 2 hours. You might have a button for pi. If you do have a button for pi, use the button for pi. It'll help you. If you don't worry about it. Like I'm looking at this calculator right now. Pi is over here. It's actually one of the second buttons, like one of the extra features. So remember that if you have like a little symbol above something, to use those symbols, you hit second. For some of you, it might say something different. It's usually shift, yeah, or a different color of some sort. You hit that button, and then what you want. So this one would be second, EXP, and that would bring up pi for you. So try to use that button at all times. If you're ever desperate and you can't find it, use 3.14. But realistically, you might be wrong by a decimal place because you're rounding, right? You're using not the correct number. So try to find the button pi on your calculator. If you can't find it, ask me for help. We have area of a circle here. We're going to try it. Area of a circle equals pi r squared. Pi r is 7 because that's my radius. So times 7 squared. If you put that in your calculator, you're going to get 153.9.
0.93804.
Yeah, and we're rounding to the nearest tenth, so it'd just be 0.9.
I started out fully.
That's fine.
0.93804.
For B,
Can I do B?
Oh.
B, so you do
yeah, so you do 7 times 7. 7 times 7 times pi, right? You're only squaring the radius.
7 times 7.
Yep, because the radius was 7 times pi. And that's how you can put it in your calculator if you needed to. For B,
For that one, you just do 49 times 3.14.
that'd work too. For B, the radius is not 3. Remember that the radius is from the middle out. They've actually given you the diameter, right? All the way across. You only want half of that. So you need to calculate that it's 1.5.
I was going to say.
Sorry. Now that you have your radius, you can do your formula, which is pi times r squared. And you get that. You're going to go 1.5 squared. Remember, we've done this for like a whole unit now. If you don't know where your squared button is, just do 1.5 times 1.5.
Aaron, that was my dad.
It was?
Oh my god.
What I got is 7.1. If you don't know where your squared button is, you go 1.5 times 1.5 times pi. Right? And you can do it one at a time if you want to. That's all squared is. It's something times itself. We just reviewed that last year. Yep, so 7.06, you would look, so if we did this, we're rounding to the nearest tenth, so we're looking at that one. If it's 5 or bigger, you move that one up 1. 6 is bigger, so we round it up to 1. 7.1 would be your answer.
Where's the exponent button?
Depends on, okay, I'll look in just a second.
Right there.
Okay. Area of a regular polygon. This is where it's going to get a little bit weird because a regular polygon covers a lot of things. Polygon just means a shape with a lot of sides, right? More than 4. So it could be 5, 6, 7, 8, 9, 10. It could be whatever you really want. A polygon just has many sides. That's what it stands for. Yeah. This only works, or this formula, if it's a regular polygon. Regular means that all sides are the same. That's what's important. Yeah. You have to have all sides the same and it makes some sort of shape. We're going to learn a bunch of them. So I'll give you a picture with a bunch of them that we'll look at. But realistically, you just need to be able to identify lots of sides. Every side's the same. That's a regular polygon. The formula for a regular polygon is right here. The way you're going to do that is you're going to use something called the apothegm, which I don't know if I pronounced that right, but you don't need to know how to pronounce it. It's the distance from the middle straight out to the edge. It's like you're finding the height of just a specific spot. It's almost like a radius too, right? Like it's kind of like that. It goes from the middle of one of the lines to the middle of the picture. The next thing you're going to know is how many sides there are. Okay, so you're going to take that value, the middle to the edge. You're going to multiply it by the number of sides. In this case, it'd be 1, 2, 3, 4, 5. And then you're going to multiply it by how long each side is. And then you're going to divide it all by 2. So it's ANS divided by 2. Make sense?
Yeah.
We're going to try it.
Okay.
There's 2 polygons right here. We're going to calculate the length or the area of them. You're going to follow the formula A times N times S, all divided by 2. A stands for the distance from the middle to the edge. That's 4. Times N. N is the number of sides. We have 1, 2, 3, 4, 5 sides. Times S. S is the length of your side. The length of your side is 4.5. All divided by 2. So I have 4 times 5 times 4.5, all divided by 2. You should get,
I want to answer.
Yeah.
45.
you get 45.
Can I get the next one? I'm almost done.
Yep.
Okay, now
But don't say it out loud yet. I'll ask you on it. Just wait. That's probably the hardest one, right? Like these polygons. Distance from the middle to the outside times the number of sides times the length of a side.
I saw that.
Bear down. You got like 4 minutes left.
could you let us out early?
Never.
Never.
If you look at B and we tried to use that formula, you do from the middle to the outside. Middle to the outside is 17. Times the number of sides. There's 1, 2, 3, 4, 5, 6 sides. Times the length of a side, which is 24. And then you divide it all by 2. Mackenzie, what'd you get?
So 12 and 24. 12, 24.
Yep.
I'm not gonna-
1,224. 1224.
Brand doesn't want to say
Yeah, you get 1,224 as your area of that regular polygon.
that. $1,200.
24.
That's 1,000, right?
1,200, no, sure.
Great, it's 1,200.
Okay,
Jake.
when we come back, we're going to go over composite shapes, and then we're going to name some polygons.